They told us to be careful, not in a movie, not as a rumor, as a real scientific warning. When antimatter was first confirmed, it wasn't celebrated as a miracle. It was treated like a problem, a dangerous one. Because antimatter is not just rare, it is unstable, and when it meets normal matter, both are erased instantly. No explosion first, no fire, just total conversion into pure energy. That single fact alone scared physicists. But the deeper warning went far beyond destruction. Most people heard the word antimatter and thought of futuristic fuel or science fiction weapons. Scientists saw something else. They saw proof that reality itself is fragile. In this video, you will learn what antimatter really is, not the simplified version, not the safe version, the version that made some of the smartest minds in history pause and rethink everything. You'll learn why antimatter showed us that the universe should not exist at all, why its discovery exposed cracks in the laws of physics, and why the true danger of antimatter has nothing to do with bombs or technology. There is a reason antimatter is kept locked away in laboratories, created only in tiny amounts, and destroyed almost as soon as it exists. It is not because we can't make more, it's because controlling it is nearly impossible. Even a microscopic failure would mean instant annihilation, but that's only the surface. The real warning came when scientists compared matter and antimatter closely. They expected perfection, exact opposites, perfect balance. Instead, they found a tiny mismatch, so small it almost didn't matter, except for one thing. That tiny difference is the reason stars exist. It's the reason galaxies exist. It's the reason you exist. Without that imbalance, everything would have wiped itself out at the beginning of time. No light, no space, no future. That realization changed physics forever. Antimatter didn't just challenge our technology, it challenged our understanding of reality. It showed that the universe survives not because it is perfectly designed, but because it is slightly broken. In this video, we'll break down how antimatter works in clear, simple terms. We'll uncover why scientists were more disturbed than excited by its discovery. And we'll explore the unsettling idea that existence itself depends on a mistake that could have gone the other way. This isn't just about particles, it's about how close everything is to disappearing. By the end of this video, you won't look at the universe as something solid and permanent anymore. You'll see it as something balanced on a knife's edge, held together by tiny flaws we barely understand. And once you see that, it's impossible to unsee it. So stay with us until the end, because the final truth behind antimatter is not comforting. It's quiet, it's subtle, and it changes everything. Welcome to the channel. If you enjoy deep science, hidden truths, and ideas that challenge how you see reality, make sure to subscribe. New videos like this are coming, and you won't want to miss what's next. Antimatter is not science fiction. It is real. It is created in laboratories. It is measured. It follows rules. Every particle you know has an opposite version. An electron has a partner called a positron. A proton has an antiproton. They have the same mass. They behave the same way. The only difference is their charge. One is positive where the other is negative. On paper, they look almost identical. That similarity is what makes antimatter so deceptive. It feels harmless. It feels like just another mirror of nature. But that calm appearance hides a serious danger. The moment antimatter touches normal matter, the rules change completely. They do not merge. They do not bounce off each other. They disappear, both of them. In that instant, their entire mass is converted into energy. Nothing is left behind except radiation. No known reaction in nature is as clean or as complete. There is no waste, no residue, just pure energy released at once. That is why even a tiny amount of antimatter carries enormous power, far more than chemical reactions, even more than nuclear reactions. Nuclear energy only converts a small fraction of mass into energy. Matter and antimatter convert all of it. That difference is what raised alarms among scientists. This was not just a new particle, it was a new kind of reaction, one that did not scale gently. One mistake would not grow slowly, it would end instantly. That is where the warning truly began, because something so powerful does not need to be large to be dangerous. It only needs to exist. The problem became deeper when scientists asked where antimatter came from in the first place. According to everything we know, the Big Bang should have created matter and antimatter in equal amounts. Same numbers, same energy, same chance to survive. If that balance had held, the early universe would have destroyed itself completely. Matter would meet antimatter everywhere. Space would fill with annihilation events, and after that there would be nothing left. No stars, no planets, no light, no observers. Yet here we are. That means something broke the balance. Somewhere in the earliest moments of time, matter gained a small advantage, not a big one, not enough to notice easily, just enough to survive. That tiny excess became everything we see today: galaxies, atoms, life. But no one knows why that imbalance happened. The laws of physics do not fully explain it. Experiments have tried to measure differences between matter and antimatter. They found small asymmetries, not enough to solve the mystery. Each answer creates more questions. Why does matter behave slightly differently? Why does antimatter lose? Why does the universe prefer one over the other? These are not abstract questions. They point to gaps in our understanding of reality itself. Antimatter is not dangerous only because it can destroy matter. It is dangerous because it reveals that the universe is built on an unexplained exception, a rule that failed just once, and that failure became everything. The first real warning did not come from fear of destruction. It came from equations. Antimatter forced physicists to admit something uncomfortable. The laws of physics were not as complete as they believed. On paper, matter and antimatter should behave the same. In reality, they do not. The differences are tiny, almost invisible. But those tiny differences decide whether a universe exists or vanishes. That realization was deeply unsettling. It meant reality was not stable by design. It was balanced on small numerical gaps that could have gone the other way. A change so small it fits inside an equation can decide everything. This idea shook physics more than any explosive possibility. Explosions are events. They have limits. Instability at the foundation of reality has none. It suggested that the universe is not guaranteed. It is conditional. That thought stayed with scientists long after the first experiments ended. As research continued, curiosity pushed humans further. We learned how to create antimatter, not naturally, not easily, only by forcing particles to collide at extreme energies. Even then, the amounts produced were microscopic, a few particles at a time. Creating antimatter was difficult. Keeping it was far worse. Antimatter cannot touch normal matter, not walls, not air, not containers. It has to be held in place using electric and magnetic fields, suspended in empty space, never allowed to slip. The technology works only under perfect conditions. Any failure, no matter how small, ends the experiment instantly. Storage is not a box. It is a constant balancing act. One error means annihilation. This made one thing clear. The danger of antimatter has nothing to do with size. It has everything to do with control. Even a tiny amount cannot be treated casually. The power is not gradual. There is no warning phase. It goes from stable to gone in a single moment. That alone was enough to make scientists cautious, not excited, careful. But the warning ran deeper than laboratories or technology. Antimatter revealed something fundamental about existence itself. It showed that the universe survives because it is unbalanced. Matter won by a narrow margin, not because it was stronger, not because it was meant to. It just did. Perfect symmetry sounds elegant. In reality, it would mean total annihilation. No leftover particles, no structure, no complexity. The universe exists because symmetry broke, because something went slightly wrong at the beginning. That idea is difficult to accept. It suggests that existence is not the natural outcome of physical laws. It is the result of an exception, a small flaw that never corrected itself. Once that is understood, reality looks different. The universe no longer feels solid or safe. It feels sensitive, delicate, governed by rules that magnify small differences into cosmic outcomes. Minor variations do not stay small. They grow. They decide everything. Physics stops being a system of guarantees and becomes a system of balances. Antimatter exposed that truth. It showed that reality depends on imperfections, that stability comes from imbalance, that the same laws that allow existence also contain the possibility of total erasure. This changed how physicists view the universe, not as a machine built for endurance, but as a structure that holds together because of tiny asymmetries that never fully resolved. Antimatter was never just a warning about power. That idea was the distraction. The real message was quieter and far more unsettling. It warned us about balance, about how close everything is to not existing at all. Matter did not win because it was stronger or safer. It won by a tiny margin that science still cannot fully explain. That small difference became stars, planets, and life. Without it, the universe would have erased itself in its first moments. Existence is not guaranteed. It is the result of a fragile imbalance that could have tipped the other way. The universe feels stable only because its flaws hold it together. Perfection would have meant nothing survived. Symmetry would have meant silence. What we call reality exists because something went wrong and never corrected itself. That is the warning beneath the warning. Not about destruction, but about how easily everything could vanish. If the universe exists only because something went wrong, what happens if it ever goes right? If this video made you see reality a little differently, make sure to like the video and subscribe to the channel. More deep stories like this are coming, and you won't want to miss what's next.